Okay, so I'm sure this is the math that is in Matt Bagnato's head as he's running around the bases. He's like always thinking about related rates and thinking about how far away he is from home plate and how that distance is changing, right? So let's figure this out. It says a player is running from second to third base. Okay, second's up here, third's down here, and we know that this we know the distance between all the bases is 90 feet. Okay, so he's running from second to third, or this player is running from second to third, and as they're doing that, their distance to home plate is changing. So they're somewhere between second and third. Let's just give them a spot. Let's say they're like right there. Okay, this is their distance to home plate. What are we calling that variable? S. So here's our distance S from home plate. Okay, so think about what's happening to this distance. As they start on second, they're pretty far away from home plate. And then as they run to third, that distance is going to keep getting shorter and shorter and shorter until they hit third, in which it's going to be like 90 feet away, right? So we're trying to figure out how quickly that distance is changing, given that the player is running at 28 feet per second, okay? So what we're going to do is we're going to call this distance X, the distance between the player and third base. And then we want to find ds dt. That's what it's asking for. So first thing we're going to do is relate x and s using a formula. So we have x squared plus 90 squared. That's equal to s squared. So then we're going to differentiate implicitly. We get 2x dx dt. And that's going to equal 2s ds dt. All right, what do we know? We know dx dt is negative 28 feet per second. It's negative, careful, because this x value is getting smaller, right? As he runs closer to third, that distance is getting smaller, so it's decreasing. So x is negative 28 feet per second. And where is he? He is 30 feet from third base when this is happening. So x is 30 at this point. So we have 2 times 30 times negative 28. That's from our given information. And that equals 2s ds dt. Crap, that's two variables. We want to solve for ds dt. We need to know what s is when x equals 30. So we're going to come up here and solve for s when x is 30. We get 30 squared plus 90 squared equals s squared. So let's just take a square root of that, right? In the calculator. I'm sure it's a nice number. They probably made it so it's simplified nice for us. So 30 squared plus 90 squared is 9,000. Okay, the square root of 9,000 is, it's not very nice. It's 94.868. Okay, that's fine. So we have 2 times 94.868. And then that's multiplied by ds dt. All right, so really quick, we got that s by just doing Pythagorean theorem up here, solving for s, when x was 30, because it told us he was 30 feet from third base. So now we're going to simplify, divide. Really quick, the 2's are going to cancel when you divide by 2, right? So those are gone. We get 30 times negative 28 is negative 840. We get negative 840 over 94.868. That's ds dt. So let's simplify that. That's equal to negative 840 divided by 94.868. That is equal to negative 8.85 feet per second. So what that tells us is the player is running from second to third at 28 feet per second. He's getting closer and closer to third. This distance is getting smaller. S is also getting smaller, and at the point when he's 30 feet away from third, it's actually getting smaller at a rate of 8.85 feet per second.